The first problem asks us, which of these data sets can you use mean and standard deviation to estimate the population percentages? So what this is really asking you is which one of these is normal, because it's the normal curves that you have been learning about how to use the mean and standard deviation for, right? The mean in the middle, standard deviation on either side. That's only true what all the things we've been learning for normal curves. So this right here is a normal curve with the mean in the center. This right here is a normal curve, that bell shape with a mean in the center and then one standard deviation, 2, 3. But this isn't normal and that's not normal, right? This is skewed to the left. And this one has that extra, this one's not symmetric at all. So we can't use the things that we've learned in this unit on these two distributions. So now we need to explain your answers in words. I said it out loud. You need to make sure you write this down for the test review and the test. If it's not on the test, I can't give you credit for guessing. I need to know that you really actually understand why. That's the important part, is the explanation. For problem number 2, for normally distributed data, what percent of the data falls within 1 standard deviation of the mean? What percent falls within 2 standard deviations? And what percent falls within 3? And you want to have these memorized for the test, right? So remember, if we have a standard deviation, that bell shape, there's the mean. So 1 standard deviation, remember, this is that 68%. 2 standard deviations, that's that 95%, so 95% for that one. And then 3 standard deviations, that's almost all of the data, right? So much so that's 99.7%. So for this question, 99.7%. You don't need to explain that. That's just a rule you need to have memorized so that you can use it. All right, below is a sketch of a normal curve right here, right? On the same axis, you need to sketch a normal curve that has the same mean, but a larger standard deviation. So the same axis, sketch a normal curve. So that means we're going to need to have a bell shape. It needs to have the same mean. That means the center needs to end up here, but a larger standard deviation. So larger means more spread out, right? So we need to have a bell shape that has its center at the same place, but it needs to be more spread out. Okay, so see how these have the same mean. And their center's the same, but mine is more spread out. If you needed a smaller standard deviation, it would need to be less spread out. So it would be taller and skinnier, right? Okay, this last one below the sketch of a normal curve, this is another sketch of a normal curve, and on the same axis, sketch one that has the same standard deviation, but a larger mean. So this time we want it to be spread out the same. It needs to have the same pretty much shape, same height, same spread, but a larger mean means that it's shifted. This mean is here. If we want a larger mean, let's put that mean up here. So we need to have one that pretty much looks the same shape, but ends up being a larger mean, shifted up. If it was a smaller mean, it would shift down.